Usman, are you there?
Yes, sir, it's recording.
Okay, thank you. Okay, so we got this. So first of all, we want to find the acceleration. The acceleration would be found out by, say this is F. We have 5 kg, right? And the force is mg sine 30. And acceleration we want to find. This is 5 times 9.85. Sine 30 equals to 5 times A. So 5 will cancel out. This will be, let me try. 9.81 times sine of 30. So it is 4.91 meters per second square. So we got the acceleration. Now we want to find the displacement. We use SUVAT. The displacement is, okay, we need initial velocity is 0, final is not known, acceleration is 4.91, and the time is 0.8. So the best equation will be S equals to UT plus half AT squared. This will be 0, this will be half, 4.91 and 0.80 whole square. So okay, I'm getting 1.58, which is of course A. All right. If you have any questions, please let me know. All right. Now, what is not a statement of one of Newton's laws of motion? A body exerts a force on body Y, body Y exerts equal and opposite force on X. Okay. Well, I've heard it. If there's no resultant force X on body, it has constant velocity. All right. Then it says the rate of change of momentum is proportional to resultant force acting and takes place in the direction of force. Well, that is also somehow true. If the total momentum is interacting, there is no external force. This is not a Newton law. This is momentum. This is not a Newton law, by the way. These three are all Newton laws. Okay, so then the graph. Describe the acceleration of the object at time ty and z. You make a tangent. Here the acceleration is 0. Here it would be something. If g is here, then it's less than g for some reason. Acceleration is at z is 0 and 0, and it is decreasing for sure. Okay, this was easy. Then it says 2 balls, one of mass 2m and 1m collide. The diagram show their initial final velocities, which the equation is not elastic. For these sort of questions, I always tell you to make u1 plus v1 equals to u2 plus v2 on the side, and then check. Then check the direction. All of them are right towards the right for some reason. I don't know why. Mass are irrelevant in this equation. So 4 plus 2 and 1 plus 5. 4 plus 2, this is 6 and 6, elastic. Okay, then let's check this one. 6 plus 4 and 3 plus 7, 10 plus 10, elastic. 8 plus 5 and 8 plus 2 is equal to, so 8 plus 5 is 13, 13, 10. This is not the last step. Let's check the last one if there are two possible answers. Always check all the answers, please. 10 plus 6, 4 plus 12, 16 and 16. So this should be our answer because this is not elastic. So that's pretty simple. Masses don't matter by the way. Now, a pellet of mass m traveling hits the stationary block. The pellet gets embedded and causes the block to move. Fine. Neglect the small increase in the mass of the block is pellet mass is added to during. Why would you want us to neglect it? Chalo, if he says, fine. So initial momentum m1 u1 plus m2 u2, and when something you use this word, he uses embed. It means mass 1 mass 2 moves with velocity. It works like this, by the way. So initially, pellet has mass m, its velocity is u, and the other one stationary. The pellet becomes embedded. The pellet of mass 2m, when a pellet of mass 2m traveling into u, it's a block. Wait a second, what is this? The pellet becomes embedded and causes the block to move speed v. Okay. So it says, I don't know what it says, but mass m. It's saying me to ignore that. Fine, I'll ignore it. And then in the next one, it says 2m u, 2m and 2u, 0. And now this is still m. And what will be the velocity? So we want to find this. Okay. So this will be mu equals to mv, the first equation. The second equation will be 4mu equals to, let's say this is 2m, 2mv2. Okay. Now mu can be replaced with this. So 4mv equals to 2mv2. M and m cancel. 2 divided by 4 is 2. V equals to V2. So it has to be 2V then, isn't it? I think it should be 2V. So you can check the answer, please. Confirm this because this is quite simple. I don't know why this is even a question. But a rigid circular disk of radius r has a center x, number of forces, okay, which element provide total momentum of 2Fr. So it's talking about torque of a couple, and 2Fr is this one. Not even like, this is torque of a couple. Now, if you don't know what is the torque of a couple, I just want to tell you, they should be equal forces acting on different line of actions. They should be opposite to each other, and they should be on the same mass. So that's fine. Parallel to. Okay. Then what is the value of W? 15 Newton. Okay, so there's an equilibrium at the very center. So 1.5 from here. So this means this will be 0.5. 50 newtons. This is going to go clockwise, anti-clockwise. W times 1, 50 times 0.5. Why is he giving such questions? 50 times 0.5 is just 25. Why? This is O-level question. Now, in high wire circus acts, a man mass of 85 kg is standing at rest at the midpoint of wire. The wire on the either side of man is at angle of 20. What is the tension T in the wire? Okay. His weight is going to be like this. Okay. Now we want to find the tension. Tension will have two components. One to the left, upwards, and this tension also left, upwards. So basically these two components are responsible to hold this. This is 20 degrees, alternate angles. So this will be T sine 20, and this will also be T sine 20. So T sine 20 plus T sine 20 is equal to W. That is the weight of the man. So 2 times T sine 20 equals to 85 times 9.81. Now it is very easy to solve. This is 1219. 1219 has to be this one then, I think. Okay, so this is pretty simple, and then go forward. And the block of ice sinks in a vertical distance d. What is the value? Oh wow. Oh wow. This is something. This is a good question now. So the reason why it should sink is that if the bare weight is down, the up thrust should be equal to the weight. So first of all, we will find, because this is this, so 400 and 9.81 is equal to up thrust, and up thrust is density G and delta V. So 400 times 9.81, density of water is this 9.81, and this is area times delta H. Now area I think is also given, that is 12. Okay, let's cut it off first to make it simpler. 400 equals to 1020 times 12 times delta H. Now this is pretty simple. Oh, 400 divided by 0.33 0.33 centimeter, no meter. So multiply by 100. ये तो सही नहीं आ रहा. What is this? What is this, my friends? 0.33 ये होगा ना, फिर C होना चाहिए.
सर 0.03 नहीं था?
0.03 था. अच्छा, एक सेकंड लेट यू. Oh yes, it was 0.03. 0.033, which is this then. 100 से multiply करेंगे, centimeter आ जाएगा, right? That's cool. Okay, the ball thrown vertically upwards, the resistance. Which statement is correct? Total energy of the ball. Well, this is correct. Total energy should be same. But principal component momentum of ball. Ball का momentum नहीं रहता, constant. System का रहता. Kinetic energy of the ball is greatest at the greatest height attained. That's wrong. Potential energy constant rate. That's wrong. It doesn't. It changes with other factors as well. Okay, a hammer is 10 joules kinetic energy, hits a nail, pushes. Both hammer and nail come to rest. What is the approximate average force? So this is the amount of work that is done. Work is force times distance. 10 divided by 5 into 10 is. This paper is so easy. I don't know why. Why they've made it so easy. Like every question is like 2000. Every question is like, O-level question. Now, the change in gravitational potential energy of an object in mass m moving through height near this. Okay, which equation is a part of derivation? This can't be the one. This cannot be the one. Weight equals to this could be one. That makes sense to me. This doesn't. The reason is that it's written here, mg. So that's fine. Okay. The racing car has an output power of this when it's traveling speed of 60. What is the resistive force? So output power, constant speed. Okay. Power is force times velocity. Constant speed means that this power is also needed at the back. Kilowatt times 60. So ये क्या कह रहा है? That's wrong. 300 kilowatt. 300 divided by 60 is 50. 5 kilonewton. Okay. That should be the answer then. All right. Now, what is the spring constant? Mass. Okay, so there's a spring and it's saying this distance we're measuring. So the extension. 3.8 centimeter. Change in mass. 40 gram. Okay. K 40 times 10 raised to minus 3. When you want to change it to kg, 9.81 for force, and 3.8 times 10 raised to minus 2, because we want to change it into meters. This is 10.3. Okay, this wasn't that hard. Same. Okay, how much work is done to increase extension by 2? By 2, half times 2 times 10 raised to minus 3, and force is 40. Okay. This cancels out. 10 minus 3. 0.04 should be the answer, but this is the increase. Why does it say the increase? The wire is already extended by, this is wrong, sorry. It says it is already extended by this much. And if I increase, till 60, it is here. And if I increase to, what will be how much work is done to increase? Oh my God, this is something. Okay. So initially it would be 60. And afterwards it will be 100. And then we got to subtract these two. So let's try. 0.25. Zero point 0.9. Eh? ये तो बहुत ज़्यादा आंसर आ रहा है. That's not fair. 0.9
It was 0.09, that's why. So the
Yeah.
final answer will be C.
Okay, that's cool. Okay, he's talking about this. Then the speed of water waves is given by this wavelength ng. Student measures the wavelengths and frequency of number of waves. Which graph should he plot to give a straight line through origin? Okay, let's check. All of the graphs are talking about either lambda and frequency. So first of all, I would like to change this into V is equal to F lambda, right? So F lambda whole square equals to G lambda over 2 pi. This will be F square lambda square equals to G lambda over 2 pi. Lambda and square will cancel out. So F square over G lambda over 2 pi times 1 upon lambda. So now straight line from origin would be y is equal to mx. On y-axis you will draw f square. On x-axis 1 upon lambda. F square, 1 upon lambda. D has to be the right answer. So please do that. If he says something like with the y-intercept, then you have to compare the equation with y on x plus c. So that's more like math. Oh, finally. Relief questions. Now, which graph shows how the kinetic energy of the air particle varies? Okay, so the displacement, when the displacement is maximum, kinetic energy should be 0. That I'm sure of. So it's either this one or this one. These two are wrong. 100% wrong. So I'm checking this one now and this one. When the displacement is 0, the kinetic energy is maximum. Right. And right. Okay. And when the displacement is maximum again, it is 0. Oh, this is wrong. Because it's not even time t and it's 0 again. So it will be 2 times maximum when t comes, and at t it should be 0. D has to be the right answer. Okay, so that's pretty simple. Then this one, the speed of sound. What is this? Okay, so gas. Okay. Okay, very easy. So first of all, we're going to take the change in length. And then $66.4. And then first loud sound means antinode and antinode, which is equivalent to half lambda. So lambda will be 2 times 6.4. Okay, now we have speed and we want to find frequency. Okay, we convert this to meters. Uh, 256. This has to be the answer. Very easy. Now going back. Emergency vehicle
Wait, 1
sound.
second.
Yes.
I don't get the question. This one, yeah.
Yeah, okay. So it's saying that the wave, like the wave, station wave formed at 85, first one. So loud sound was heard, which means antinode was formed. And the next one, it was formed when it was like, next one formed here. Okay, no, like this.
Isn't the bottom a node?
It is not. But we're checking out, I mean, when the water, it says when the water was here. when the water was here, there was a stationary wave formed. Okay. When the water was again here, there was a stationary wave formed. Do you understand?
Yeah.
So the next time stationary wave forms, which means the distance between this to this has to be node to node or antinode to antinode. It's fine. It's still half lambda, right?
Yes.
Doesn't matter. Okay, so too loud sound means too consecutive means that it's an antinode to antinode. Okay, or node to node. What does describe? Okay, so a person stands X, person stands at Y. So its frequency is this. So X will hear lower frequency, and that would hear higher frequency. But the vehicle is accelerating. Accelerator means that its speed is increasing every point. So it will feel lower, but decreasing frequency as well. It's not like just the same. And increasing frequency. This should be the answer, because as it speeds up, right, as the acceleration is there, the more the velocity of the vehicle is, the greater the change in, greater the apparent frequency is gonna be. That's fine. Now, what is the name of shaded region? This is, oh my God, this is O level. No, this is not O level. Visible light, infrared. Infrared. And infrared is somewhat here. Now you guys should learn this because there's no other way. Okay. You could also think that visible light is 10 raised to -7. How could infrared be -8 then? That's wrong. Now, the three waves shows diagrams. They're added together to result in which case the resultant wave 0 at this instant. Wow, Hannah, this is crazy drawing. Impressive. This, if I check this, this is less amplitude than this, right? So this is not going to cancel everything. And at this instant, I check this and this is almost same. So I think this should be the answer. This cannot cancel, this cannot cancel. It's wrong. Because amplitudes should be exactly opposite, like exactly same magnitude but opposite. It has to be this. Okay.
The mark scheme, it says A.
Why? Why does it say A? This is
No.
not fun. Oh, I get it now. That is good. Okay, I'm wrong. Sorry. I'll tell you why. Because actually there is one wave like this, and there's one wave like this, which has an amplitude like this, and there's another wave like this. Very clever now. So it has amplitude like this. So this and this added up will make even bigger amplitude. Here, this wave, amplitude this, and this wave, amplitude this, against this wave, amplitude this. So these two added would almost be the same. That's why it is there. Very good. This was the only good question. Okay, now. So this 28. All right. What is the reason for this? Radio waves are coherent, but microwaves are not. That's not true. I mean, it can go and then it diffracts more because it has greater wavelengths. I think so. So this should be thinking. Radio waves are diffracted around the mountain, but microwaves are not. Okay, this is happening. The radio waves are reflected. Nope. Radio waves travel at, nope. They both travel at speed of light. Okay, an experiment is carried out, demonstration, double slit. The moment I read double slit, I should remember AX equals lambda D. Wavelengths, again. Distance between bright fringes and interference is x. What is the possible values of distance between slit screen and the slit separation? So this is A, this is D. So to do this very quickly, what I'm going to do is, this is crap. I mean, look at this, what they've done. All different, units. I don't like them at all. So 5 into 10 raised to power minus 3, 510 raised to power minus 9, and D. Now, the thing is, you can just pick your calculator and keep putting in the values so that this and this is same on both sides, right? So if I say for the first one, you multiply 5, okay, 0.5 times 10 raised to power minus 3, and with 5 into 10 raised to power minus 3. Mera calculator, it's not good one. I don't know. Okay, so can somebody please check this my calculator? I don't want to do this on this one. ये है, चलो फिर भी मजबूरी पर 2.5 times 10 raised to minus 6. And what is this? I hope iska A will answer. I will be the happiest person on earth. Okay, this is 500 and times 10 raised to power minus 9 and times 50 into 10 raised to minus 2. Okay. No! This is wrong. Okay, now let's check the next one.
Sir, let's check C first.
Okay, let's check C first.
Yes.
Okay, because, all right. Okay, I'll take your suggestion. Let's check C. So slit distance is 500 times 5, 0.5 times. Okay. All right, I'm checking this. So 0.5 times 10 raised to power minus 3 times 5 into 10 raised to power minus 3. Okay, so this is 2.5 times 10 raised to minus 6. Okay, and then 500. In your calculator now, I think there is an equation, sort of an equation thing too, I think. Okay, 0.9 and times 5. Okay. Yay! That is correct. Okay. Thank you. Oof, this is a bad question. Now, light of single frequency is incident refraction grating. 7 bright spots observed on a screen. Which change will result to increase the number of bright spots? You should decrease wavelengths. That I know. If you decrease the wavelength, increase the distance between screen. Increase the frequency. Increasing the frequency is decreasing the wavelength. This should be the answer. Intensity doesn't do anything. This doesn't do anything. Increasing number of lines per grating would reduce it actually. That's not fine. Okay, electric field. Nope. Nope. Oh, this is cool. What is the equivalent electric current in the edge of the disk? What is the frequency? N revolutions per unit time. So 2 pi r is the distance and speed is equal to distance over time. N revolutions per time. So n times it is revolving in this. and 2 pi, and the radius is r, and it will rotate like 4q times n over t. I don't know what I've made, but chalo. 8 pi r q n over t. There is no t. What is this? That's wrong. I have to do something else. There's no t. So I have to think. The speed will be distance over time. So what will I do with speed really? I can't do really anything. Current equals to charge over time. Okay. So there are 4 charges per unit time. So equivalent current, I will find current. Now, so, and how many times the n revolutions per time, per unit time. So this means n is equal to revolutions per unit time. So I can replace this here. So this will be 4q n. Why is there a radius? There's no use of it. So it has to be a then. Radius is not needed really. Okay, in a circuit shown, a fixed resistor X is connected in series with battery and variable resistor. The power dissipated is 7.2, current is this. The variable resisted, so the power dissipated in X increases by 50%. What is the new current in the circuit? Wow. What a question, huh? The power dissipated 7.2 and current is 3. The variable resistor, just as the power dissipated, increases by 50%. 50% means 1.5 times 7.2. So this is 10.8 watt is the new power. What we can do is we can find the voltage across this. For that, I would use power is equal to VI because voltage should stay the same if the resistance isn't changing. For this one, this guy. So 7.2. Okay. This is a clever question actually. Very, very clever. 2.4 volts. This wouldn't change because here it's fixed resistor. Now we have the new power. We want to find the new current, VI. Voltage is the same. All right. Why did I? 4.5 ampere should be the new current then. Okay, so 4.5 ampere. But why? Why? Let me have a look at it again because this is not a very simple question. So there's a resistance R. Would the voltage stay the same? This is a question. I don't think so voltage would remain the same. Because if this changes, voltage is going to change. This will change the voltage. This is wrong. Sorry, resistance will stay the same. So I need to find the resistance, not the voltage. Power is equal to I square R. By the way, the new power was 10.8, I believe. So 3 square R 7.2. 0.8 ohms. Okay, this would stay the same. Now, power equals to I square R. Okay. 10.8 divided by 0.8 and root of answer 3.7. This should be the answer, not that. Please, B should be the answer. I got it wrong in the first place because I took the I thought voltage is same, but it's not same. It is going to change.
I don't get this. Where did you get the 10.8 from?
It's increased by 50%. So if it was like 100% equals to 7.2, then 150% will be 10.8. Do you understand? I cross multiply
Yeah, okay.
like that. All right. Okay, going forward then. A resistor and a filament lamp are connected. The potential difference across resistors is 3. What is the resistance of the lamp? This is the resistor, this is the filament lamp. The potential difference across the resistor is 3.3. They are in series, right? So they're going to share it. 3 voltage means that the current in the circuit is going to be the same, and this is 2.8 ampere. Now, for 2.8 ampere, the voltage across this is 3.2, 3.4, 3.6. So, V is equal to IR. 3.6 divided by 0.3. No, 2.8, sorry. One point three. What is this? ये तो आंसर ही नहीं है. कोई और चीज तो नहीं हमने मिस करती.
Sir, it's 3.3 from the resistor. I think we took 3, right? That's why.
It's 3.3
From the across the resistor.
Okay, let me check why I've done. It is 3. 3.3. Let's check it again. This is 3.2, 3.4, 3.3. Okay, right here, which is 3. Okay, fine. 3 means that this is going to go here, and this will be 4.2 then. Okay. All right, but the thing is, this is not a linear curve, and why am I using V is equal to IR really? Does it make sense? I don't think so. It does. I should be taking because abhi bhi. Okay, let's try anyway. Okay, 4.2 divided by. Yeah, that's fine. We can do that. It won't make any difference though. Even if you take the gradient, it will be the same. So I think it should be the answer. Please do verify the answers. I don't have anything right now except for this. Okay, car battery has electromotive force 12, internal resistance of this. What is the terminal across the battery? Right. The car battery is 12 volts, internal resistance. The battery is connected starter motor. Current is 160. What is the terminal potential across the battery? Okay. 160 ampere, like EMF equals to terminal potential plus voltage loss. You want to find this? So EMF minus I small r will give us this terminal potential. 12 minus 160 times 0.05. So let's try. That has to be 4 volts then. Yep, this is pretty simple. Okay, then this circuit. Wow. देखने से डर लग रहा है. The reading on voltmeter is 0. Oh, okay. If the voltmeter reading is 0, this means whatever the potential here is also the potential here. For some reason, this is what is this circuit? I don't understand this at all. What is the resistor R? Is this series? Is it parallel? So I would like to redraw this. This is not happening. So basically, there is a resistor 3, and then there is another resistor 14.4. And across this, there is another resistor R. Okay, whenever something this happens, right, very complex, and I can see that these are the points where they're parallel. So I would like to recreate them into straight drawings, because then it helps me. I don't know if it helps you or not, but it helps me basically a bit in understanding of it. So this is 4, and this is the battery. And exactly between this point, let me change the color, and this point, there is a voltmeter that says 0. So this is the drawing actually. Now it doesn't look that scary to me. Okay, so I'm just assuming, I'm not saying anything. I'm just assuming this to be 12 volts. So this means that the voltage here and across this has to be the same. It should lose the same amount. That's what I'm actually thinking. But, okay, let's say this is 12 volts. So across this hole, it will also be 12 volts. So I want to find what is the value of voltage across this. So I can use the potential divider formula. V out equals to 2 over 2 plus 4.80 times the EMF. Okay, so this will quickly let me find it. 2 divided by, okay, very strange, 2 plus 4.80 times 12. This is 3.53 volts. Okay, so if this is 3.53 volts, like this is 3.53 volts, this means this is also 3.53 volts. This means that this gets 12 minus 3.53, yani 8.47 volts, and this also, this whole gets 8.47 volts. Now the point is, how is it going to help me? That's the question. Well, it could help me if I say V equals to IR. I could make 2 equations. Well, I could do that. And also for the whole one, I could make 1 equation. Well, okay, I have an idea. Maybe it works, maybe it doesn't. So I'm going to take this whole thing and then check how much current is there, right? So to do that, well, why can't I just find the current directly? Wait, V is equal to IR. I could use this circuit. No, I can't do that. Sorry. I have to use V is equal to IR. Okay, so first I'll solve the total R. So total R will be 1 upon 14.4 plus 1 upon R equals to 1 upon R in parallel. And I don't know what to do next. So I'm just gonna 14.4 times R. This will be R plus 14.4. Okay. And then I'm going to take reciprocal. How complex this question is. Now I'm realizing it. Okay. All right. So this is the resistance and 3 ohm. This is the total. Let's call this total R. I don't care. Let's call this just R. This is the total resistance across this section. Okay, I'm only looking at this section. So the current here should be I, and the resistance is the total resistance. Let's call this total, and the voltage is 12. We know this. So this is our first equation. In the second equation, unfortunately, For this one, we have the voltage as 8.47. The current would be the same because this section and this section is series, and however the resistance is going to be the R parallel resistance. Okay, so let's keep that in mind. Now we got two equations, and two equation means that we can now substitute each other. Okay, let's try. 12 over RT equals to 8.47 over RP, and 12 times RP equals to 8.47 RT. This is too long. There has to be an easier way. Why isn't there an easier way? Why? Okay, never mind. Still, let's do this. Then I'll think of an easier way for some reason. Well, this is R plus 14.4 over 14.4 R, and this is 8.47, and the total is this equation. Oh my God. How are we ever going to solve this? I'm not going to do this. Okay. Let me think, please. No, I'm not going to do this. This is I can solve this, but it's going to take like forever. Like 14.4 over R plus 14.4 plus 3. If I do this, I have just one variable. I can solve this, but it is going to take forever. I cross multiply, then it will be like, whoa, man, that's too good. I can't do this. I have to think of another way. So basically, I assumed there is 12 volts. I just assumed. And I also know there's 8.7 volts on the top, according to this clue that they gave us. What I can do is why don't we use the answers and put it back and check whether this gives me the same ratio. How could I do that? I could do that by, I have a great idea. V out equals to, somehow I want, see, I'm getting it. I want resistance in parallel. No, I'm not going to do that. Wait a second. Okay, yeah. Resistance in parallel over resistance in parallel plus 3 ohm times the total EMF is 12. And this is 8.47, right? Now, what I'm going to do is I'm going to find what is the resistance total should be in order to get this value, right? So let's do it. Ab ye ho jayega. 8.47 RP plus 8.47 times 3, 25.41, and this is 12 RP. Okay, so that goes there. So 25.41 equals to 12 minus 8.47, 3.53 RP, and RP will be 25.41 divided by 3.53. That is 7.2. 7.2 ohm हमें चाहिए total scale if we want to win. Now I know my answer is going close because one of the answers is already there, which is not right. So I know C is not correct, but I'll check now. So 1 upon RP should be equal to 1 upon R plus 1 upon 14.4, and 1 upon 7.2 is equivalent to 1 upon R plus 1 upon 14.4. I'm going to use my calculator. I think it should be 14.4. I think. Yep, this is the answer. Whoa. Can you please check this answer?
Yeah,
Tell me
it's
if
C.
Yay!
Could you explain all of this again?
Yes, now I can. This was the best question up till now. Okay, so basically what I did was, let me go through very slowly. I looked at the whole system and I was like, let's recreate it. So this is parallel from this end, like I can see. So I made two resistors, 4.80. I made this resistor. Up till this, you understand, right?
Yes.
And what I did then was I assumed a value here, like I assumed 12. So if 12 is here, it means that all of this is 12 volts. Do you understand? Because it's parallel, right? So it said there is a voltmeter that shows 0. It means the potential on these two sides are same. So then I tried to find what is the potential across 2. So I used V out equals to 2 divided by 2 plus 4.80. Whatever the potential I get here would also be the same here because there is no difference, and 12. So I got it like, what did I get? I don't know. 2 divided by 2 plus 4.80 and multiply by 12. So I got 3.53. Okay. Anusha or whoever asked me. Anusha was asking.
Yeah.
So I got this voltage. It means that 3 exclusively got 3.53, and then this section, which is this section, this would get the rest, which is 12 minus 3.53. That was 8.47. Okay, Anusha?
Yes.
Then what I did was I actually found, I used V out again. I found what is the value of the whole parallel resistance through this formula, because I know the total voltage was this. This is RP. This is 8.47 across it, right? This voltmeter. So I got RP to be 7.2. Then I use this and to find what is the resistance for the parallel formula. You see.
Yeah. Okay. Got it.
This is a distinction question, actually. Very good. Okay, sliding contact is moved through P and potentiometer, then Q. What are the two readings? If the sliding contact is moved from P, for some reason, why is there's a current going like this? Here the current is going like this. Isn't it going opposite? Oh no, it will go here and then it can go here. Yeah, it's not opposite, it's the same. Okay, fine. So at end P, the sliding contact, the voltmeter should show you exact the potential across these 2 points, and the potential across these 2 points will be 3 for sure, because वो battery खुद ही दे रही है ना, so it's either 3 or 3. If it is put across this, now there is a potential of 3 and 3, so there are 2 batteries, right? So it will provide, both of them are providing current in the same direction. It means the potential is going to add up. The series में batteries है. It has to be 6. B a answer. All right. Okay. What is the conclusion from alpha particle scattering experiment? Conclusion is that the nucleus contains most of the mass of the atom. सामने नजर आ रहा है. Electrons were never talked about. Protons, yeah, they knew about protons. Electrons, they never knew about it. Neutrons, they never knew about it. Okay. Which particle is hadron? Proton is hadron. Done. Yay. Okay. All right. So I'm going to see you people in the next class. If you have any questions, please let me know from this worksheet. I mean the paper.